Continuing with Module 3, which covers the third homework and the third quiz. Hopefully we'll finish Module 3. This last thing we're going to do is something pretty different and new, and it's called trig graphs. And as we start creating these trig graphs, you're going to see that one of the things I use is the unit circle. We just had a couple lessons on unit circle. Once again, here is the document that, remember, the unit circle allows us to easily determine the trig functions of any of our special angles. In other words, this chart goes from 0 degrees all the way to 360 degrees, or in radians, 0 to 2 pi. And the special angles are the 30, 45, and 60. And then you keep moving that same distance all the way around. And the whole key to why the unit circle is so helpful and powerful is that, for instance, if you have a 30-degree angle or a power of 6 angle, this point is what helps to form that angle. And if we want to get the trig functions, we've learned before that if I want the cosine of pi over 6, I simply look at the x value of this point, and that equals the cosine of pi over 6. So the cosine of pi over 6 will be square root of 3 over 2. If I wanted the sine of pi over 6, whenever you look for the sine is always the y value of the point. So the sine of pi over 6 would be 1/2. If I were to say go to the third quadrant, say I was told find the trig functions for a 7 pi over 4 angle. So that means you start here, you go all the way around to right here. Once again, the key is you just have to know what the x and the y are. Since the x is square root of 2 over 2, I would say the cosine of 7 pi over 4 is square root of 2 over 2. And I would say the sine of 7 pi over 4 is negative square root of 2 over 2. So now, by using the circle, we're going to do something different now. These are called trig graphs, and here's what we're going to do. I'm going to first make a table and put some numbers inside this table, and then once I have the table, then we're going to create another graph. Not a graph like the unit circle, but a different kind of graph. So here's what I want to do. I'm going to start out with an angle, and since normally when I do angles, I call it angle theta. But what I'm going to do is I'm going to pick an angle, and for that angle, I then want to determine the cosine of that angle, and then also the sine of the angle. As you know by now, these are really the two main trig functions, cosine and sine. Everything else we can figure out if we know the cosine and the sine. Here's what I'm going to do now. In a sense, I'm going to start, and I'm going to do this in radians. I'm going to start at a 0 angle and then put down, so what is the cosine of 0? Well, the cosine of 0 is 1, and the sine of 0 is 0. How did I get these so quickly? It's because I know the unit circle. Angle 0 is right here. I know this point is 1, 0. The cosine of 0 is 1. The sine of 0 is 0. And what I'm going to do is I'm going to start putting in different angles. What I'm going to do is I'm going to eventually move around this unit circle. I'm just going to put in some different angles and then write down the cosine and sine. Now, I'm not going to choose every angle. Matter of fact, I'm going to keep it really simple. You know what I'm going to do? I'm going to choose what I call sort of the really simple major points. I'm going to start here at 0. Then I'm going to go to pi over 2, and then I'm going to go to pi, and then 3 pi over 2, and then up here to 2 pi. And then maybe for fun, I'll go around again and do a few more. So let me just see what that looks like. So I'm going to go ahead and look at the angle pi over 2, and then I want to look at the angle pi, then 3 pi over 2, and then 2 pi. Now if I keep going, let's just do a couple more points for fun. If I'm at 2 pi here now, and I want to go up here again, I add pi over 2 to 2 pi, which ends up being 5 pi over 2. Then if I go another 3 pi. Let's go all the way around twice. So now I went around the circle twice. 0 to 2 pi, then 2 pi to 4 pi. Now let's figure out what the cosine and sine is for all these angles. And this comes directly from knowing the unit circle. Cosine of pi over 2 I know is like the top here. The cosine is the x value, so I know it's 0. The sine is the y value, so I know it's 1. If I have the angle pi is right here. I know the cosine of pi is -1 and the sine of pi is 0. Now once again, I'm showing you this unit circle, but I hope you realize on the midterm exam and the final exam, you have to really have this unit circle memorized so that you can know the trig functions of these special angles. So if I go to 3 pi over 2, 3 pi over 2 is down here, so this is my point, 0 minus 1. So the cosine is 0, the sine is -1. Now at 2 pi, I'm back over here where I started. The cosine is 1, the sine is 0. If I go around again, actually you're going to see that these points sort of repeat. 5 pi over 2 is really the same as pi over 2. Remember we called those coterminal angles? They actually start and stop at the same place. 3 pi is coterminal with pi. So they have the same trig function. 7 pi over 2 is just like 3 pi over 2. And 4 pi is just like 2 pi. So I've created this table. Once again, just to review, I'm looking at various angles as you move around the unit circle. And for each angle, I'm figuring out what's the cosine of that angle and what's the sine of that angle. And for me, the easiest way to determine these was just to use the unit circle. Here's what I'm going to do now. Now I want to go ahead and I want to graph. Now, let me do this. This could be a little confusing, but we have to do it because this is how the book does it. It just made sense to me that when I created this table, my angle was theta, and then here are my trig functions. However, what we're going to do now is, in the book, instead of using theta, they still like to use x, where x is now an angle. They just like the variable x. So in a sense, instead of calling the angle theta, we're going to call the angle x. So this is really cosine of x, sine of x. And here's what we're going to do. We're going to make two separate graphs. And the equation we're going to first graph is y equals cosine of x. Where basically here's my x, And this is going to be the cosine of x, or I can also call this y. So you know what it's almost like? Let me just, I know this can be confusing. Let me do a quick example. If I were to give you an equation, y equals 2x plus 1, and I said, let's go graph this, here's what you would do. You would put the x here. I mean, this is one way to graph it, a common way to create a table. And you choose some values for x. If x is 0, y is 1. If x is 1, y is 3. If x is 2, y is 5. Maybe we'll choose some negative numbers. If x is negative 1, y is negative 1. If x is negative 2, right? And then we could go and graph these points, right? Zero, 1, x 0, y 1, 1, 3, 2, 5, negative 1, negative 1, negative 2, negative 3. And my graph is not perfect. Basically, it should have a straight line. Well, let's do the same thing now. Instead of the equation y equals 2 sine x plus 1, let's do the equation y equals cosine of x. If I were to do that, it's the same thing. I'm going to choose some x's and figure out my y's. So if I choose x equals 0, y is going to be, what is the cosine of 0? 0 radians. Well, I know it's 1. The next one I'm going to choose, because I know this is an angle and it's in radians, I'm going to choose pi over 2. What's the cosine of pi over 2? And if you look, if I kept on going here, this right here is basically the same as these two columns here. So what I'm going to do is I'm going to graph now. This is going to be my x, and this is my y. So this column here are the x's, this column here is the y, and this is for y equals. Now here's what is a little tricky. Normally, like over here for this graph, when I made my x, my axis, it's 1, 2, 3, 4, 5. Well, look at my x's here. It's these funky numbers with pi in it. How do we even, I mean, I can draw my x and y axis, but like, am I supposed to get a calculator and figure out what pi over 2 is? 3.14 divided by 2? Well, no, what you do is you go ahead, since these x numbers all have this pi in it, here's what we do. I'm going to basically graph this thing up to 2 pi. I'm not going to do all these. So I'm going to say 2 pi is here. So 0's here. 2 pi is here. What is half of 2 pi? Well, half of 2 pi is pi. So here's pi. What is half of pi? Well, half of pi is pi over 2. So this is pi over 2. And what would it be if you go halfway between pi and 2 pi? And it turns out 0, pi over 2, pi, 2 pi. That's what my x's are here. 0, pi over 2, pi, 3 pi over 2, 2 pi. So now what I'm going to do is, now I notice with my values of y, it goes between 1 and 0 and minus 1. So I'll just, for my y-axis, have 0, 1, and minus 1. And now I'm going to go plot these points. Notice I'm going to plot x0, y1. x0, y1 is right here. Then x power over 2, y0. So x power over 2 and y0. Now when x is pi, y is negative 1. So here's pi. So if the y is negative 1, what happens at 3 pi over 2? Y is 0. What happens at 2 pi? It's 1. And let's go on, we can go on a little further. How about we go on to 5 pi over 2, which is 0. And maybe right here would be 3 pi. 3 pi is negative 1. If I had wanted to, I could have even gone negative, and I could have had like negative pi over 2. Negative pi over 2. Negative pi over 2. Remember, negative angles, you go clockwise, so negative pi over 2 is actually right here. So it would be negative 1. All right. So let's try and combine, let's try and combine these points and see what kind of graph we have. Now please, I haven't graphed every single point, but what I'm going to show you here is the general shape. You don't just connect these points like with straight lines. Instead, these are like curves. It's not always easy to, let me try and draw this. It's not always the easiest thing to do to make it look. I'm sure the book has nice graphs. But I'm going through every point. Oops, I think this is wrong. Negative pi over 2, the cosine is 0. So you know what happens? And this goes on forever, and this goes on forever. And it's like they call it a wave. Matter of fact, it's called a sinusoidal wave, where it just goes continually up and down the same distance. And it just goes on forever. This is what you get when you graph the cosine function. That's very important. Right away, the easiest way to tell whether you have a cosine function is you look at the angle 0. In this case, at angle 0, my graph has a value of 1. I know that only happens for the cosine. As a matter of fact, let's go ahead and based upon now this second column, these would be the y values if I'm trying to graph y equals sine x. In other words, this is a graph of y equals cosine x. Let's do one of y equals sine x. Now if I wanted to, x of course is an angle. If I wanted to, I could do all my points. When the angle is 0, what's the sine of 0? The sine of 0 is 0. If I go up to pi over 2, what's the sine of pi over 2? Sine of pi over 2 is 1. Then I could keep going around. What's the sine of pi? But you know what? If I were finished this table, it would look just like, here's my x's and here's the y's. So once again, I've already created this table. So now let's go ahead and plot this one. So my x-axis is like my angle, and let's go and call this right here 2 pi. So half of that would be pi. Half of that's pi over 2. And here you have 3 pi over 2. If we want to keep going, 5 pi over 2, and then 3 pi. And over here, we have negative pi over 2, negative pi. Whoops. So now, I'm going to now plot, these are my values of x, these are my y's, which is the sine of x. So when x is 0, y is 0, or it's the sine of 0 is 0. I go to pi over 2, the sine of pi over 2 is 1, so I'm up here, and then the sine of pi is back to 0, but then the sine of 3 pi over 2 is negative 1, and then the sine of 2 pi is back to 0. If I do a few more points, the sine of 5 pi over 2 is back to 1. Sine of 3 pi is 0. If I look at a couple of negative angles, negative pi over 2 once again. Negative pi over 2 means I go in the clockwise direction to right here. What's the sine going to be? Negative 1. And then the sine of negative pi is back to 0. So now, if I try and connect these dots, and once again, it's going to be a curve. I'll just draw in straight lines. Probably like something like this. I'm going to really turn this around to try and make this look decent. So here's the kind of graph. Now if you compare, if we can see them sort of at the same time, notice the cosine. This is very important. The x-axis is the same point, same everything. But you notice the cosine, of course, when the angle is 0, cosine's up here at 1. Where's the sine? It's down at 0. So the cosine starts out at its high point, and then it drops down, and then it comes back up, and then it starts going back and forth. The sine starts at 0, then it goes to the high point, and down, and back. So those are the two main trig graphs. And once again, what have we done? The x is my angle. The y is, in this case, it's the sine of the angle. And we simply went to sort of the 4 major points on the unit circle. We got the data, and we made our rough sketch of a graph. So those are really the 2 key trig functions. But what we've gone over now is the very, very basic. In other words, we looked at y equals cosine of x, where x is an angle, and y equals sine x. Well, these are the very, very base, and most of the times this is not what you end up having in problems. Instead, you'll have things like, sometimes you have a coefficient in front of your trig function. Sometimes you have a number in front of the variable x inside the cosine. And there's all kinds of and you can have even a number tacked on here to the end. Sometimes you have negatives. So the question is, I know the graphs are my very basic functions, but how will throwing in these extra numbers begin to affect my graph? And it's very easy to determine this. It's not very hard. Matter of fact, here's the two sort of standard equations. You have A is going to be like a number, A times cosine. This is really a Greek letter, it's not W. I think it's supposed to be like omega. Omega x. The other equation we have for the sine looks the same. Now, what happens is we give A a special name, actually the absolute value of A, so it's always going to be positive. Maybe you've heard of a word like this, the amplitude. The amplitude means how far is it. If we think of like the middle of the graph in terms of up and down, the middle of the graph in this case is my x-axis. The amplitude says how far is it from the middle of the graph to the highest point. So that's what amplitude is. If you look at a graph, the amplitude is just how far from the middle of the graph to the highest point, or how far from the middle of the graph to the lowest point. It should be the same number. And it's always positive. When you give an amplitude, you always just say it's a positive number. So that's what the A is. This omega in here, or it looks like a little W, what it does, we can use it to do a calculation for this large T, which I'm going to explain in a minute. Because T is called the period. Let me go look at the graph and explain the period. The period is how far you have to go in the x direction until the graph begins to repeat. Because these kinds of graphs just keep on repeating forever and ever. Now, but the question is, how far do you have to go before it starts repeating? Usually the easiest thing to do is to check, like here it's pretty easy. I could start at the top here, then it goes down, and comes back up, and you come back to the top, and you know what? That tells you what your period is. I would say in this case, if if I go from pi over 2 to 5 pi over 2, I've actually gone a distance of 2 pi. That would be my period. The period is how far it takes for the graph to begin to repeat itself. So if you look at a graph, once you determine the period, you can plug the period in for t, and this gives us a way to calculate omega. Or I could say, if we move things around, the omega, or that w, equals 2 pi over the period. So for instance, for this graph, since the period's 2 pi over 2 pi, omega is 1, and omega is the number that you multiply the x by that's in the cosine or sine, and since it's 1, it just looks like this. So let's review that. Here are my two possible trig. There are actually more trig graphs than these, but we're just going to focus on cosine and sine. This is like the general equation. Y equals a times cosine omega x. Y equals a times sine omega x. First step is to figure out whether your graph is a sine or a cosine. And once you figure that out, you can always find the A. The A is the amplitude. From the middle of the graph, how far up or how far down does it go? That's the amplitude. The period is how long it takes. I should put that there for period. How long it takes for the graph to start repeating. And when you figure out that period, that gives you a way to calculate this omega. And then since you know a and omega, then you're able to actually determine the equation. So basically we have two things. We have equations and graphs. So now we're going to take some time. We're going to first look at some equations, and based upon the equation, we're going to figure out the graph. But then after that, we're going to look at some graphs, and from the graph, we're going to try and write the equation for that graph. All right, so let's do a couple examples real quick. First, let's just take a couple of equations and try and create the graph. So let's say y equals 2 cosine, and how about we're asked to create the graph of this. So here's what you do. Of course, you need to know the amplitude. Amplitude's easy, right? It's always just a number in front of the trig function. And I don't care if that number is positive or negative. You just always make it positive. Amplitude's always easy. Now remember, here's my standard equation. Let me write here. Since A is 2 and omega is also 2, since A is 2, absolute value of A is the amplitude. Absolute value of 2 is just 2. Amplitude Remember, we call t the period. And here's this little equation. You're going to have to memorize that for the test. You will not be told that. So the period equals 2 pi over omega. From our equation, omega is 2 pi over 2. So now we've determined that the period is pi, the amplitude is 2. Now I'm going to, when I get ready to graph, I'm going to take this period and do one more step. I always take the period and I divide by 4. Because when I divide the period by 4, that sort of tells me where I should put my steps or my marks for my graph. In other words, you know, when I did these graphs, I went from 0 to 2 pi. Well, here, the period is going to be how far I'm going to make my graph. Now when I divide it by 4, this tells me what are the sizes of the pieces. In other words, pi over 4. Once I have a period, I always break it up into 4 equal parts. I break it in half, and then in half again. This number here, pi over 4, is going to be the step size, or how much you move. In other words, this is 0. This is pi over 4. If we go pi over 4 more, we're into pi over 2. And this one's 3 pi over 4. The reason I break it up into 4 equal parts is because as I graph it now, these are the points where I'm either at the height or the bottom or maybe passing through. Now, since this is a cosine, first of all now, okay, also second thing I didn't mention, since my amplitude is 2 now in my graph, instead of putting a 1 there, when I draw my graph, it's going to go all the way up to 2 and to negative 2. So since it's a cosine, remember when I first did the cosine graph, my first graph? Cosine always starts high, it goes low, then comes back high. Right? Cosine is 0. If I put in 0 in for x, cosine is 0. That whole thing is just 2. But I don't need to even look at this equation now. I just look at these points here and I realize a cosine starts high. At the next point, it hits 0. Then if you keep going, it goes down to the low point. Then if you go, it comes back to 0. Then if you keep going, it goes back up high. And if I were to connect these, now if I wanted to, I could keep this going on. And it keeps repeating, but this is adequate. This is the graph of y equals 2 cosine of 2x. So let's review that again. I'm given this equation. I'm given a cosine equation, a cosine function. Right up here, I write the general function. I realize a is 2, omega is 2. Once I know A, I know my amplitude, so I know how high and how low my graph is going to go. That's really always very easy. Then the period, I have this little formula to use for the period, 2 pi over omega. Since I know omega is 2, period ends up being pi. And when I get ready to graph it, I know I have to break up this pi into 4 equal parts. So I divide it by 4, so I know as I graph this thing, you're going to move pi over 4. So I did my pi here, and I cut this up into 4 pieces. Pi over 2, pi over 4, 3 pi over 4. And then, because you know it's a cosine at an angle of 0 starts out high. In this case, at the next point it goes to 0, the next point it goes low, then back through 0 and up to the top. Let's graph a sine. How about so we're asked to plot or graph or make a rough sketch of y equals 4 sine of 1/2 x. The first thing I sort of say to myself is I have to remember sort of what the sine graph looks like. Remember the sine graph, when the angle 0 starts at 0, goes high, comes back, goes low, back high, and keeps on going. But the key is, once again, A is 4, omega is 1/2. In order to try and graph this, I need to know the amplitude. Of course, the amplitude is the absolute value of A. Amplitude is going to be 4. The period, T, is 2 pi over omega. Omega is actually 1/2. If you simplify this, it ends up being 4 pi. Now remember, I'm going to do my whenever I get my period, I'm going to divide it by 4. So every step is going to be like pi. So since I know my amplitude is 4, I'll just make this mark 4 and this -4. Of course, this is 0. If I know my period is pi, I'll just go maybe right out to here. Of course, I know if I cut it in half, pi over 2. If I cut that in half, pi over 4, 3 pi over 4. Now, since I know it is a sine wave, I know it starts at 0. At my first point, it goes high, comes back to 0, then goes to my low point, then back to 0. So if I try and draw this now, and there's your sine wave. Amplitude of 4, a period of pi, right? All right, so I hope you will not find those too hard. Now in the, there's a couple little twists I think they throw in the homework, so let me just discuss the impact. One of the things they will do is 3 cosine of, let's just say, so the difference is now, up until now we've had equations like this. Now at the very end, we add on a number. This number ends up pretty straightforward. It causes a vertical shift. Now here's my advice about doing these graphs. The vertical shift I'm going to include at the very end. So it's almost like, for now, I ignore this. I'm just going to graph this, but then I have to remember at the end to include my shift, and I'm going to have to sort of redraw it. But for now, let's just figure this out. So A is 3, which is my amplitude. Omega is 4, so the period is 2 pi over 4, which is pi over 2. And if I divide by 4, so actually pi over 8 is going to be my steps for my graph. So let's go ahead and draw my graph. Once get it to cosine. So my amplitude's 3, so I'll just mark 3 up here, -3. My period is going to be pi over 2. So here's pi over 2, and of course when I draw my period, I break it up into 4 equal places. Pi over 8, so I start here at pi over 8, and then this is 2 pi over 8, which is actually pi over 4. That's 3 pi over 8. And now, because it is a cosine wave, I know cosine starts high, then it goes to 0, then it goes low, then back to 0, and it ends high. But what I'm going to do is, normally at this point I draw in my graph, but because the very last step is I have to account for this vertical shift, all I've got so far is this function right here. So I'm going to plot that, but I'm going to do it like in dashed lines, which tells me it's not really the final answer. It's just like a temporary intermediate graph. So in other words, if I can do this, I want to sort of lightly so there's the graph of simply 3 cosine 4x. The vertical shift is very simple. If the vertical shift is like this, a +2, that means you take the whole graph and just move it up 2, the whole thing. If this would have happened to have been a -2, then you take the whole graph and move it down by 2. So in other words, what's going to happen is 3 is right here. This is going to go up to like, maybe to like 5. It's 0 here. It's going to go up to right here. So I'm going to draw my new points. If it's -3 here, it's going to go up to about right here. This one's going to go up to here, and this one goes up to here. And now I go ahead and draw in my sort of new graph. So then this right here is my final . All right, so the new thing here was this vertical shift. Pretty straightforward. You sort of ignore it at first, figure out your graph, then you come in at the end and do the shift. Now one more thing, then we're all done with these trig. Oh, we're actually not done. Well, one more thing you're going to see. It might do something like this. Let's have a couple new things. How about if I do what if we say to graph this? Well, there's no vertical shift, but my A, right? Here's my A is -1. The omega is 2 pi. That means the amplitude's the absolute value, is going to be 1. The period, which is 2 pi over omega, 2 pi over 2 pi, the period is 1. And what's interesting is, up until now, if you look back at all the examples, all the periods we calculated all had a pi in them. And because of that, here this period was pi. This period was 4 pi. But sometimes they make it like this, where because they stick a pi into the original equation, you end up with the period just being a number. But I'm still going to divide by 4. So you get 1/4. And then you go here. First of all, the amplitude, okay, now here's what's interesting. The amplitude is 1. But this minus up here is going to change things. And what I'm going to do once again is I'm going to first ignore the minus sign. And I'm going to graph sine of 2 pi x. Because what the minus sign does, it causes what we call a vertical flip around the x-axis. Let me get that in a minute. Let's first, I'll do a dotted line graph of sine of 2 pi x. So first of all, amplitude is just 1. Period is 1. So if I break it up into my 4, so it'd have 1/4, 1/2, 3/4, and 1. Now since it is a sine wave starts at 0, goes high, back to 0, goes low, back to 0. So this right here is the graph of sine of 2 pi x. Now to include the negative, what's it mean when you do a vertical flip around the x-axis? That means you take this graph and you just sort of rotate it like 180 degrees. You flip it around the x-axis. So it's this whole thing, if you can imagine this thing flipping over, then it's going to end up being like this, right? If you look at the dotted graph, if you just flip it, and then this right here is finally the graph of that equation. Now the last thing I want to do, and this will hopefully go fairly quickly, is also on the homework and on the quiz, sometimes everything I've done so far is taking equations of these trig functions and graphing them. And by the way, I have focused solely on sine and cosine. If you go to your book, they give you examples and walk through how to graph tangent functions and even secant and cosecant and cotangent. I don't have the time to go through all those, and I don't think there's much of those on the homework, but it is in the book if you're interested or need it for something. Here's what I'm going to do now. Now, let's take a graph and figure out the equation. Most of the time, the first step you do is you have to determine is this a cosine wave or a sine wave? And the whole key is what happens when the angle is 0. So look at here, here's my axis. 0, pi, 2 pi, 3 pi, 4 pi, up and down, 0, 2, 4. Here's my starting point. When this thing starts, my graph is high. Well, what is that, cosine or sine? This is where you have to remember. You go way back to our first graphs. Remember, here was the cosine graph. How does the cosine start out? Starts out high. This must be a cosine graph. What I'm going to do is now, I know the equation for the cosine is this. There's no vertical shift. Really, you know what? I need to determine if I can figure out what A is and what this omega is, then I've got the equation. I just have to figure out what A is and omega is, find numbers for those. Amplitude equals A. Amplitude is really always easy to determine from a graph because once again, it's the distance from the middle of the graph to the highest point or the lowest point. Hopefully you can see this goes up to 4 and down to -4. Hopefully it's pretty clear that the amplitude is 4, which means A is 4. So I know A. Now if I can figure out omega, then I'll have the equation. How do we find omega? Well, we have this equation for the period, which is 2 pi over omega. If I solve for omega, I can really say omega is 2 pi over t, where t is the period. So if I can plug in my period, I can calculate omega. Well, I can look at the graph and find the period. Remember I said the period is how far it takes for the graph to begin to repeat. Easiest thing to do is you start here at 0 and it's going down. So I'm going to keep tracing my graph until I get to the top and go down again. So here I go down, 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 down. I'm at the bottom. I come up. I haven't started repeating yet. I come up. I come to the maximum and then start down again. At this point now, I'm beginning to repeat what's over here. Okay, so that means the period, the distance where it starts to repeat is from here to here, which it looks like in this graph, it says 4 pi. So t is 4 pi. So now, if I plug that in here, omega would be 2 pi over 4 pi, which is 1/2. So now I've got my A and my omega. I can say the equation for this graph is 4 cosine of 1/2 x.